Today we're going to talk about analyzing the velocity time graph. So we have been working on, We have been working on displacement time graph, right? Recall what we have done so far is this thing called the position time graph. Okay, so it's telling you at what time where you are. Okay, so if I have a line that's like this, it's telling you that at 0 seconds, the person is standing at 0 meters. So if I have a number line, the person was standing right here. And then at, say, 5 seconds, it is now at 5 meters. So as time goes on, he would have to travel to 5. And then it keeps going at 10 seconds. It is now at 10 meters. So it keeps going. And that's what position time graph is. So another way is, I want you to write this down. Okay, position time graph basically tells you where you are at what time. Okay, so where you are at a certain time. And that's what a position is, where you are, right? Position, where you are at a certain time. Okay, now we're changing the graph. Instead of graphing the location or the positions, we're now going to draw the velocity. So at each of the time, how fast you are going. And that's what a velocity time graph is. Okay, so velocity time graph is at each time, how fast you're going. Okay, so what that means is, if I'm given a position time graph and I wanted to be able to make a velocity time graph. Okay, quiz time. I know I talk about this. If I have a position time graph, if I would like to calculate the velocity, what do I have to calculate of it? Remember, your rise over run, right? So my slope is equals to the velocity. Okay, so I need to, from a position time graph, work out what the slope is so that I can put it in velocity. Okay, so that's why they're saying you're going to have to first of all section off the graph into different slope. So if the slope change, we kind of block them together. We calculate the slope and then we match the time. So the example they have given you is you got a position time graph that has 3 sections. So what I would like you to do is you would want to block this off. So see how we're going to block off the 3 and we're going to block off the 6. And these give you the different segment, meaning between 0 and 3 seconds, the velocity is the same. And what I'm going to do is I'm going to call them A, B, C. And I'm going to find the slope. So the slope for A, meaning the velocity, is you're going to pick 2 points from that graph. So this point, and you're calculate the slope. So this is 0 and 0, and this is 330. So 3 seconds and 30 meters. So to find the slope, y2 minus y1 over x2 minus x1. When you're doing A, B, C, I only need you to write the equation out one time. Okay, so y2 is 30 minus y1 is 0. x2 is 3 minus x1 is 0. So 30 divided by 3, I got 10 meters per second. It doesn't say direction, so I'm just going to say forward. Okay, we already talked about for slope, it's the same for the whole segment of 10. So if I found 10 to be the velocity, that means between 0 and 3 seconds, it is traveling at 10 meters per second. So I'm going to draw a line that is 10. Okay, done for part A. Let's do part B. Okay, part B, the slope for part B. What's the slope? What's the slope for a horizontal line? Bing, yep, 0. Okay, if you want to do the calculations, you're totally welcome to, right? So if you wanted to, you're going to find 2 points. I'm going to use the same first point. You can use this. So this is 6 and 30. Okay, if you want to do the calculation, is 30 minus 30 over 6 minus 3. 0 divided by 3 is 0. Okay, but if you want to, you can do the calculation. Okay, so they're telling you between 3 to 6 seconds, the velocity is 0. So I find the 0 line and I draw a horizontal line like right here. Okay, last one. I have 630, like 0.630, and then I'm going to have 9 and 0. Find the slope for part C. Velocity is y2 minus y1 divided by x2 minus x1. So 0 minus 30 is negative 30. 9 minus 6 is 3. Negative 10 meters per second. So that means between 6 to 9, the velocity, which is the slope, is negative 10. So at negative 10, I'm going to draw a line. Let's change it back to the same color. Okay, I know the lines are disconnected because it has a sudden change in velocity, so we're going to leave it as like that. Okay, do the same thing. Pause the video. Do your calculation of the slope. Okay, block it off. I'm going to use some dotted line. Fancy blue color. Okay, the segment that I'm going to have is the 6 second. Going to extend it to the bottom, and then the other distinct slope is 10, 14, 16, 15, sorry, and then up to 20. I'm going to find the slope of each of the segment, label them first. First, A, B, C, D, E. I'm going to calculate the slope. So for part A, the slope represents the velocity is y2 minus y1 over x2 minus x1. Okay, pick my 2 points. 0, 0. This point looks pretty good. This is 6 and 12. So y2, which is 12, minus y1 over x2 minus x1. So 2 meters per second. So that means between 0 and 6, I put it right in the graph. 2 meters per second. Part B, what's the velocity at B when it's a horizontal line? Velocity is 0. I'm going to fill in 0. See how if I block it off, I can easily know how far I should extend it. Okay, part C, pick 2 points. This one point right here, which is 10 seconds, 12. And I'm going to pick this point at the bottom. This is 14 seconds, and this is hard to tell. I'm going to say it's around 2. It's not quite half. I'm going to say 2. So between 0 and 6, but it's not quite half. I'm going to say about 1/3, so I'm going to use that. Velocity is y2 minus y1 over x2 minus x1. 2 minus 12, and then 14 minus 10. So this is negative 2.5 meters per second. So between 10 and 14, I'm going to have negative 2.5. So somewhere around down here. Part D, velocity or the slope. It's a horizontal line, so it's 0. So at 0, I'm going to put in the horizontal line. And then finally for part E, find the slope. To pick 2 points. See how repetitive it is? You just keep finding the slope, but the only thing different is you transfer it over to the graph. So at 15 seconds, it was at 2. And then right at the top, at 20 seconds, it is at 24. So y2 is 24 minus y1, which is 2, divided by 20 minus 15. So 24 minus 2 is 22, divided by 20 minus 15. which is 5. So 22 divided by 5, I got something like a 4.4 meters per second. So between 15 to 20 seconds, it is 4.4. I'm going to draw a horizontal line like that. Okay, not too bad. Position time graph to velocity time graph, I find the slope. Okay, next. Now we're moving on to something else. Instead of finding the slope, they're saying if they give you velocity time graph, sometimes they can ask you to find this thing called the area under the graph. Okay, the area is always measured from 0, so I'm going to draw, this is 0. This line is 0. And I want to find between 0 to 3 seconds, what is the area under the line? This is the line, right? So the area under the line between 0 and 3 would be this area. Okay, the shape of that is a rectangle. So the area is length times width for a rectangle. I'm going to include the unit because I want to know what I'm finding. If I have a velocity time graph and I find the area, so this is from 0 to 3 seconds. So this is 3 seconds. The length is 3 seconds. What is the height or the width? From 0 to 5, the unit is meters per second, so it's 5 meters per second. Do you see how I'm reading the axes to tell me what the size is? Okay, so length is 3 seconds times the width, which is 5 meters per second. 15. Are we okay? 3 times 5. Okay, unit though. Let's study the unit. If I have meters per second multiplied by seconds, one way to write meters per second, it really means meters divided by a second, and then this is second at the top. These cancel, I'm left with meters. So what they're trying to tell you is so there's like a little relationship. If I have a position time graph, if I calculate the slope, it gives me velocity. If I have a velocity time graph and I calculate the area, I'm actually going backwards and finding the meters, the positions. Do you see that? So that's the relationship. So you're going to have to be careful which graph they give you and what they're asking for. Okay, how about between 3 to 5 seconds? I'm asked to find the area under that. So between 3 to 5 seconds, under the line, I have to find this. So area is still length times width. The length is between 3 to 5 seconds, so it's 2 seconds. And the height in here is 2 meters per second because it goes from 0 to 2. 0 to 2. Okay, so 2 seconds times 2 meters per second. So this is 4 meters in total. What does the area underneath the velocity time graph? Make sure you highlight it. This is an important part. Area under a velocity time graph. We already talked about that. It's actually your displacement. So it's telling you how far did you travel. Okay, so they want you to create a position time graph from the data above. So just now, between 0 to 3 seconds, 0 to 3 seconds, it has traveled a total positions of 15 meters. So with 3, it goes to 15. You draw a straight line. Because it's traveling at a constant velocity, if you remember on the last lesson, something that's a constant velocity is the straight line. So this is a straight line up here. Okay, and then, now this is the tricky part. For the second part of the question, for the last 2 seconds, I've traveled an extra 4 meters. So from 15, I've now traveled at the end of 5 seconds, I think. Yeah, at the end of 5 seconds, so right here, I have to travel an extra 4 meters. So I'm at 15. That means I am now at 19. It's 15 plus 4. Okay, I was standing at 15. I have to travel an extra 4. So I draw a straight line up here. Okay. All right, when creating a position time graph, calculate area. So this is the steps. So they want you to first of all, so create a position time graph from a velocity time graph. They want you to calculate area between the line and the x-axis, and then use the area as your displacement, and then you would connect the two consecutive points. Okay, remember, horizontal line of a velocity time graph means constant velocity, meaning on the displacement time graph, it is a straight angle line. Okay, let's do it again. One more example. Okay, so this is a velocity time graph. I would like you to find position time graph. That means each step along the way, I'm going to have to find the area first. So if they really want to trick you, they're not going to say, hey, you need to calculate the area. They will just say, I want position time graph from velocity time graph. From your knowledge, if I have velocity time graph and I want to find the position, I need to find the area. So that's something you're expected to know. Okay, let's do the first one. The first one is between 0 to 3 seconds. So this is your first block. To find this area, I'm going to call this block 1. Area for 1 is a rectangle, so length times width. The length is 10 meters per second. The width is 3 seconds, so I get 30 meters. So between 0 to 3 seconds, I have traveled 30. So I start from 0, I go to 30, put a dot here, and I draw a line. Okay, that is after 3 seconds. Okay, now I'm going to do from 3 to 5 seconds. Area 2 now will be these guys. Okay, I have length times width. The total is 2 seconds. And the height is 4 meters per second. So a total of 8 meters has been traveled for this. I was at 30. I now have to add 8. So 30 plus 8, that equals to 38. I'm just going to make a little mark. I know that I've ended at 38 meters. Okay, I do another straight line. So I'm at 38 because I've added 30, adding the 8. Okay. Next one. Next one, this is the 0, and this one, nothing happened. Okay, I have no area under the curve. I didn't travel anywhere. So that means I was at 38. I didn't go anywhere. I stay at 38. This, at between the 7 seconds, I actually have stayed at the 38. Finally, my last block is this one between these two guys. These are the area. Okay, so area 4 is going to be length times width. So the total is 1, 2, 3. So 3 seconds in total. And the height or the width is 6 meters per second. Are you okay with how I got the 6? I would read and line it up to the number, right? See how it says 6 over there? Helps if I don't cover it, right? So that's where I got the 6 from. So 3 times 6, 18 meters. So I now, from 38, I have to add 18. So 56 is the ending point. So at the end of 10, I am now at 56.